Welcome back. Today is day 25 of the daily LeetCode grind. Probably going to do 2 hours today, and then with segments of 20, how we usually do it. I know 90 minutes is the ideal learning time, but just need more time under tension. So, yeah, trying to do a little bit more. So, that being said, reflections on yesterday, fried insert interval, but it wasn't in the exact 20-minute time limit that I'd like to do. It was like 22 minutes. That being the case, I want to give that one another shot. Also, the solution I used was nlog nbound, and I feel like there's a way to just insert it where we need it to be. I mean, we should be able to insert a number into, essentially a number into a list. Like that should be, we should be able to do that. So the fact that I couldn't do that yesterday or that it was getting messed up was just weird. So we want to fix that. Insert interval and do it in under 20 minutes. At the same time, we haven't gotten back to LRU cache, so we want to do that. And at this point, I feel like at the same time, it's important to keep doing maintenance. So maybe we'll do the first hour on maintenance. Then we'll do the first hour until we run out of problems. And then we'll do another, and then we'll probably do insert interval and LRU cache. And then maybe another new problem. That one would be blocked by 3 problems, which is a little bit difficult. So I also went through grind 75 and knocked off problems I've already done. We technically did insert interval already, so we could technically add that. And I'm pretty sure we did majority element, but I don't remember. We did a lot of the easies already. So yeah, we need way more medium exposure, like we said, especially tree exposure. We just need a lot more tree exposure. A little bit bummed we haven't gotten as much tree exposure, especially so far. So honestly, if we can do like half of the problems in something, so there's 10 problems in a week, it looks like, or approximately. If we could, we already did insert interval, so if we could do that one, I would consider this array week done, and hopefully we can figure out the rest. And I'm just going to jump to week 2 and then start doing some in here. That way at least we'll have done half of every week, getting some sort of exposure to all problems. My graph and binary search trees / binary tree / hash table / recursion exposure / heap / tree / dynamic programming / backtracking is trash. There's so much we haven't covered. But if only there was more time. But we should have to do one more in this one, and then we can jump to this one, and then so on and so forth. And we're gonna slightly hinge towards the harder problems, so hopefully that pays off. That being said though, want to start with or maybe we'll just go all the way through. Honestly, I'm always caught between exposure and doing new problems, but at the same time, it's just as important to look over your old games. But at the same time, attacking your weakest area is usually where you're going to get the most gains. And we do have some weak areas. Also, surprisingly, I wonder if I order it by topic. What is this ordered by? No grouping. What if I group by order by topic? If you order by topic, I think it becomes a lot more straightforward. In terms of stack, I think we touched on stack so many times that I feel relatively okay with it. There's just so many other things we barely touched, like binary search tree and binary tree. I don't even know how powerful it is that we spend more time in array, to be honest. So we might do 3 sum and then just keep going. But yes, it is what it is. I wonder if you make the time really small, what does it do? Interesting. How does it know how to do this? What is it doing? 1 week 3. Interesting. It looks like this separation of problems would be 19 medium 19 easy, 14 medium. So that's pretty interesting. We also get the harder problems faster, which is, I think, is a good thing. I need more mechanisms of thought. That being said, I'm just going to jump into it. Day 24, I think. Day 25. I still have to make that YouTube video I promised to make. I still haven't made it yet. Additionally, make sure to join the Hyperbolic Coding Chamber Discord. Thousands upon thousands of people are joining every day, so that'd be pretty cool. And I'm just gonna jump into with some grease in the groove. Start with some review first, and then jump into new problems, so I don't jump in blind. Hopefully, grease up those synapses to tie it all together. So I'm gonna start both timers. Make sure I'm recording. My voice is coming through. My hat is kind of drippy today. Need more hats. And then, yes, so we're gonna jump into it. Trapping rainwater, yeah. So yeah, at this point we're just doing review. We did this one yesterday, but we're starting to feel pretty good about it. So it is what it is. So you have function trap. We have function height, which is an array of numbers. And then we have number. So given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. So n non-negative integers are in this height array, each width of the bar is 1, and we have to compute how much water it can trap after raining. I see. And so that makes sense. So for this one representing here, we can see that we can trap 1, 2, 3, 4, 5, 6 blocks of water. And we can see that here nothing exists because there's nothing to catch that left-hand side. Same thing for this side, except it's the right-hand side. So the height n is equal to the length of the array of numbers. There's always at least one cube in the elevation map up to 2 to the 10 to the 4 elevations in the array. Height can be 0 to 10 to the 5, so interesting. So I think what we can notice is that if we were to take a look at this between 2 points, when can we catch water, right? It seems like we can catch water when for a given pair of elevations, the elevations are equal to or greater than one side. So if we look at index 1 and index 3 here, we can trap 1 cube because the black cube's height is 2, which is greater than or equal to 1, which is this left-hand cube side. And we can keep playing with this to see that even here when cube is 2 and the height is 3, that we can trap the minimum of the height of these two heights. And same here, right here we have two heights of 2. We can see that the height of the water is going to be tied to the minimum height of both, which would be 2. And if we actually look at this portion, would be 2, 1, 2. We can calculate it, right? Since there will be 3 cases, I guess, when they are the same height. It doesn't matter which height we choose because they're the same. You can calculate how much water is trapped by iterating over the range and just doing the height minus the elevation map. So we'd have 2 minus 2 here, which would be 0, 2 minus 1 here, which would be 1, and 2 minus 2, which would be 0. So the water gained in this bucket would be 1. Then we have another case, right, where the left-hand side is greater than the right-hand side. We would choose the minimum of the 2, right? Because if it was up here, then we'd have the water leaking over, right? So it would be the minimum of the 2 heights would be 2 minus 1, which is 1, minus 0, right, which would be right here, right? 2 minus 0 is 2, so we have 2 water blocks. 2 minus 1 is 1 water block, and 2 minus 3 is negative 0, is negative 1, which means we don't want to include negative answers. Calc water, positive only. So there's a fourth case, right, where it would be the left-hand side is greater than the right-hand side. But what we see with this case is that it's kind of hard to understand exactly where we would actually calculate our water. Since when we're going from low to high, we just have to go until we find something that's greater than or equal to our height. When we start high, like when do we stop? right? Do we stop here? There's no water here. Do we stop here? Well, this is a water cube. This is an n cube as well. So that seems difficult. The way I can see it in my head is to just make sure we're always going from lower to high on both ends, and we'll iterate from both sides of the array to do so. Iterate from both sides of array, left is less than right. Then we can just choose the smallest of the two smallest of the elevations. And if we have the smallest elevation, then we can just go forward until we find an elevation that's greater than or equal to what we're looking for. So we'll say I need a left and a right, and we'll say if height left is less than height right, what do we want to do? We want to calculate the buckets, right? Because we said that if we're going from low to high, we just have to find a height that is greater than or equal to our current height. To do so, right, we're going to need a variable which keeps track of that, so we can do current equals left, right? Then we want to increment left, right, to force it forward at least once. Otherwise, this will never move forward, right? So if we look here, right, 0 would be less than 1, but if we don't move this forward, nothing's going to happen. So we want to start moving left over so that even if this iteration is a bust, we can continue forcing propagation. From here, we can have a while loop, and we'll have while height sub left is less than height sub current, and we'll calculate the water, right? And we'll have potential water equals so in this case we actually can't calculate anything, right? So we just go to the next iteration. That's why we want to force one step forward. Where potential water equals there's a case where the water does exist. Let's say we're starting at this index here. We can move forward left once. Current would still be at here with height elevation of 1. How do we calculate the water? It would be height sub current minus height sub left, right? And then we would do left plus equals 1, right, to go to the next iteration. Like we said, we only want to calculate positive water only. So we could just say potential water will have water plus equal potential water. If potential water is greater than 0, potential water, otherwise 0. And so this looks good to me. And then we'll have the else case, right? So the else cases, so this would run twice, right? 0 would be less than 1. We move it forward. 1's not doing anything. Then we'd have 1 is equal to 1, so we go to the else, right? So we'd be here. So we want to duplicate our steps, right? It's going to look almost exactly the same, except current would equal right. And since we're iterating from both sides of the array towards the center, our progress step is going to be a decrement. And we want to do height sub right, is less than height sub current. Well, is height sub right, which would start at 2 here, less than height sub current? No, and this is why we have this step here to force the propagation. And then we'd have height sub current minus height sub right. Then our progress step would be right minus equal 1, allowing us to calculate the water, and we could return water. So we can double check this if we just run it on a simpler subsection. So let's just say we start with here with the 0 and the 1. The 0 and the 1, which one of these is less than the other? 0 is, so current equals left. Current is going to equal 0. Left plus equals 1, which is going to be this node right here. Is height sub left, which is 1, less than 0? Nope. So we're going to go to the next iteration with left equaling 1. Is 1 less than 1? Nope. So we're going to go into this else iteration where current equals right. So current is going to equal 1 and right minus equal 1. So is height sub right, which is 1, less than 2? Nope. So we're going to go to the next iteration, and this is how we have these forceful progress steps here. Now we're going to have 1 and 2. So we're going to say, is 1 less than 2? Yes. So current equals left, and left plus equals 1. So now is while height sub left, which is 0 less than 1? It is. So potential water equals 1, right? Minus 0. It's positive, so we add it to water. And then we move forward 1. We're going to say, is 2 less than 1? Nope. So we have 1 so far for water, and we'll be here. And then we're going to have 2 equals 2, right? So we're going to go into else. Current equals right, which is going to be 2 here. Right minus equal 1, which is going to be 1 right here. Is 1 less than 2? It is. We're going to add to water 2 minus 1, which is going to be 1, and also positive. So water is now going to have another 1 in it, and we're going to decrement to here, right? And we're going to say, is 2 less than 2? It is not. So now we're going to 2 and 2. Again, we're going to have another step where they're going to be the same, so we're going to default to else. We're going to move forward 1 to 3, right? And then here we're going to have these two indices. 2 is going to be less than 3, right? And so current is going to equal left, which is this index here, left plus 1, which is going to be here, and we're going to do while height of left is less than height of current. Well, height of left is 1. Is 1 less than 2? It is. So we add 2 plus 1 to water, so we get 3 water. What's 2 minus 0? It's 2, so we add 4 to that. Then we have 1 again, which 2 minus 1 is 1. We add that to water. And at this point, they would be right on each other. The final iteration, so we return water. So I think we can implement this. Let left equals 0. Duplicate let right equals height dot length minus 1. We want to be last indices. Do while left is less than right. And then we'll just uncomment these lines since our pseudocode is close enough to the actual code. So high is left and height is right. And then I'll just uncomment this. And so we'll say current equals left. We'll say let current equals left. I want to hold that indice. We'll do left plus equals 1, force that step forward. And then we'll do while height sub left is less than height sub current. Then we want to do constant potential water equals height sub current minus height sub left. That checks out to me. We'll do water plus equals potential water is greater than 0. Then add potential water, otherwise add 0. So that makes sense to me. We'll add a semicolon, keep the progress step. And I think we can duplicate almost this whole thing. But actually, let's not do that just so we don't mess up any lines. Right minus equals 1. Do while height right height. So while height sub right is less than height sub current, does that make sense? I think so. We need one more. And we'll do const potential water again, height sub current, which would be, let's just say 1 minus height sub right, which would be 2. That height sub current, which would be 2 minus height sub right, which would be 1. Yeah, that makes sense. Water plus equal potential water is greater than 0, then we get the value of potential water, otherwise we get 0. Right minus equals 1, and then return water. Cannot find name current. We're not actually changing the value of currents. Both of these can be const. So that looks good. So that's pretty cool. The output of this, the time complexity of this would be linear time, since we're basically visiting the entire array, or we're going to perform an operation. Our number of operations will be tied linearly to the number numbers in the array, and our space would be constant space. So I'll reset this to 20 and pick another problem. So we have two-sum data structure design. We have a constructor, add, and find. Design a data structure that accepts a stream of integers and checks if it has a pair of integers that sum up to a particular value. To a particular value. Implement the toSum class. toSum initializes the toSum object with an empty array initially. Empty array, void add int number, adds number to the data structure, makes sense. Boolean returns true if there exists any pair of numbers whose sum is equal to value, otherwise it returns false. So toSum equals new toSum. They add 1, add 3, add 5. Does there exist two numbers that you can add to get 4? Yes. Find 7. Does there exist two numbers that you can add to get 7? No. So typically the normal way to solve toSum is just with an array and a hash map or a map. But with a data structure, I guess it depends on what you're trying to optimize for. If we tried to port the hash map one pass solution to this class, maybe we could keep a hash map, and if we try to find a number in the array, or we're trying to find the numbers, so basically in the hash map solution, what you do is you'd iterate over the array, and for any given number, or if you're given an array and you have to find two numbers that sum up to the value, every number in the array you would add it. If it doesn't exist, we would check if the target number minus the current number we're at. So let's just say in this example we're searching for 4. We would search for basically through the entirety of the array, and we would check if 4 minus 1 exists in the array, so the numbers complement, and if it does, we would return true. In that case, every time we run find, if we were to implement something like that, it would be linear time with linear space. But since we have to return if a pair of numbers, we have an edge case where if we have to find, let's say, a target 8, if we do 8 minus 4, we get a complement of 4. We need to know that there are at least two 4s in the array. So I think what we could do is have a map in it. I don't think you need the constructor because you can write these here. So we could say map and the array of numbers. And when you add a number, you would add it to the map. Well, if num exists, add to map plus occurrence, right? And then you could also add it. Do we need the array though? So if we want to find if a value exists, then I don't think we actually need an array. I don't think we actually need the array because we could just check if the complement exists in the map. So I don't think we actually need the array. So if num exists, add to map plus increment occurrence, else add to map as usual. Add to map with one op add to map, right, with awk plus 1. And then when we're doing find here, we can just check if map.has. That's what, well, we could always iterate, right, okay. So we're not missing anything. We could iterate over the keys in the map. So we could get keys from map. And they don't give us any time or space requirements for these functions. So you get the keys from the map, and we could just iterate for every. Wait a second. I think I see what I'm saying. I see what I'm saying. You actually don't need a map, because at the end, when you find the array, you still have to iterate over the keys. If that's the case, you could just keep a regular array. But if you keep a regular array, then you have to make sure that if you give a regular array, then you have to make sure that there exists two numbers, and that's the problem with the array solution, because you need to make sure that these two numbers exist, at least when you find the target by checking if the complement exists in the hash map. I think you could solve this again just by making sure that the hash map has an occurrence of 2 in the special case where the complement is the same as the value that you're searching for. So in light of doing a new solution, I'm going to do the array and hash map solution. And so, and if the num exists, add to map with awk plus 1. Right, and I think I keep going in circles because I'm like, oh, you don't need the array if you have the hash map. So let's just do the hash map one pass solution. So you get the key. So if num exists, add to map with awk plus 1. Otherwise, add to map with awk 1. We'd get the keys from the map. We would iterate over the keys, and we would just check, right? We would say, if we're iterating over the keys would be the numbers in the array. If we're iterating over the keys, well, we want to check if two numbers add up to a value. So we could say if map.has the value that we're searching for is value minus num, so the numbers complement, right? So we just declare const complement equals value minus num. Right, and we'll just say, does the map have the complement? If it does have the complement, it can't return true just yet, because if it does have the complement, then we need to make sure. And what we can do is we can say const occurrence equals map.get complement, and we can check basically a few things. We'll know if the map has the complement, right, if occurrence, right? So if occurrence, it means that the map does have the complement, right? But if occurrence means we found it, we also have to check one more thing. If complement is equal to the value, right? So in the case where we're asked to find 8, if it exists in the thing, right? And our map has a value that looks like this. 4 goes to 2, so we have 2 occurrences of 4, right? We want to make sure that we return false for the second case and true for the first case. So in the first case, to calculate the complement, we do a value, which is 8 minus 4, which would be 4. And so we're doing map.get complement, we're checking the occurrences, right? So if the complement, which is 4, equals the value, which is also 4, and another way to say this is if the complement plus the value, if the complement plus the number equals the value, well, let's just say if the complement, which would be 4, equals the value, it wouldn't, because the value is 8. There are two numbers that you have to add together. The first value that it's if complement equals the current number that we're at, because target would be 8. 8 minus num would be 4. The complement we're looking for is 4. So when the complement and the number are the same, and occurrence is less than 2, right? Then we want to return false just to catch that edge case. Otherwise, we can just return true. For some reason, our spacing is off very badly. So that looks fine there. Otherwise, we can return false. While our spacing is off very, very badly, we can return false because the occurrence would not exist in the occurrence. Otherwise, we know that the value doesn't exist in the map at all, so we know the complement doesn't exist. So in this case, we just have to, we can delete the constructor and just do map equals new map, and it'll be a number to number. And a shorthand way of populating a map is just doing const awk equals if map.has number, then we'll get the occurrences for that number. Otherwise, we'll get 0. And then to overwrite the value in the map, we can just say map.set number to awk plus 1. And for some reason, this isn't lighting up. But I see why I pushed it forward. We needed to iterate over the keys. Oof. So to iterate over the keys, we'll do for const num of map.keys. And I guess another way of doing this would just be map.entries. And then this way we could just get num and awk together. And then we return false out here. So we have the numbers and the occurrences. Here we have complement, which is the value, minus num. So let's just say we're running as so they want us to add 1. We check if the map has 1. It does not. We try to get it, nothing comes out, so we get it to 0. We set 1 equal to 0 plus 1. Then we add 3. 3 does not exist in the map, so we set it to 3, right, with an occurrence of 1. We add 5, we set it to the map, 5 with an occurrence of 1. Then we want to find 4. We iterate over all the entries, which is 1, 3, and 5. So we have the number and the occurrence. We calculate the complement, which would be 5 minus, to start 1, 5 minus 1 equals 4, right? Then we get the occurrences for the complement, and it turns out, right, we don't even care about the specific occurrences, so we can just do num of map.keys. So we get 5 minus 1 should be 4. We would check if 4 exists. We check, right. If 4, which is what we're looking for, minus 1 equals 3, is 3 in the map? It is, right? And so if the complement, which is 4 minus 3, which is 1. If the complement equals the number, which it doesn't, 1 does not equal 3. An occurrence is less than 2, then we return false. Otherwise, we return true. So let's try this out. Ugh. So we're seeing if we add 0, okay, we'd have an occurrence of 1. If we add -1, we have an occurrence of 1. If we add 1, we have an occurrence of 1. We have to find if anything subs up to equal 0. So you could add 0 and 0. We should return true, but for some, oh no, wait. I see. So the one I see now, this solution doesn't work because when we want to calculate the complement for 0, we want to find if for any number, if 0 minus 0 exists in the map, 0 minus 0 is 0. But what we really need to find is that -1 and 1 sum up to equal 0. Because any pair of numbers whose sum is equal to value, and 0 kind of destroys the whole complement process. So what you could actually do this with is an array, and I think this would actually be safer. So we'd have a property called isSorted, which would equal false, and there's a version of this you can use. We have R, which is equal to this, and we don't really need this constructor. And so whenever we add a number to the array, right, isSorted is going to be changed to false, right? So do r.push number, right, this.r, we'd say this.isSorted equals false. And so when we're finding a value, right, you can say if isSorted, or we can just do like this. If it's not sorted, right, then what you can do is just sort it, right? So we do r.sort a comma b, a minus b, right? And then we could say this dot is sorted equals true. Afterwards, right, there's a method you can use with the two-pointer approach to simply check whether or not two values can sum up to a value. And this is very similar to how you would solve another version of two-sum. So what you would do that, you could start left at one value and right at r.length minus 1. And what you could do while left is less than right, and we want to shimmy the values depending on if we can find it, right? And if we can't find two values sum what we're looking for, then we'll return false. All right, so the sum would equal to r.left plus r.right, and so we check if sum equals value, we'd return true. That's amazing, right? However, if sum is greater than target, then the best we can do to get closer is actually decrement. Right. Now, if sum is greater, the best we can do to get closer is to remove this largest value. Else, if sum is less than target, best thing we can do is increment left to see if we can add just a tiny bit more, right, to see if we can get the value. I forgot an equal sign. Also with this in almost every location. 8 seconds left. I forgot of this. 4 seconds left. Oh my god. I'm using target. It's called value. So that looks good. Now I'm seeing something. There's something about the one pass hash when you're looking for two numbers. This is why it's so good to This is why it's so good to revisit problems. Because now I'm seeing the difference between these two algorithms. They're not exactly the same. The one pass hash is an edge case for 0 that I never really realized. For this one, we're literally checking if two values sum up to it. So it's just a simpler algorithm in general. Just a simpler algorithm in general. I would still count that as a pass since I typically don't do the one pass hash version, but I wanted to implement it to see how different it would be. And it was different and we learned something, but we were still able to implement the actually good solution in like less than 4 minutes basically. So I think that's still a pass. The 24 minutes of review. Wow, I haven't done a lot of these older problems. Yeah, I've been really slacking on maintenance, I guess, trying to get new problems in. So given a string column title that represents the so you have function title, you have column title, which is a string, and a number. Given a string column title that represents the column title as appears in an Excel sheet, return its corresponding column number. So Excel usually uses letters to name columns. And the column number they want us to map to is A to 1, B to 2, C to 3, Z to 26, and A to 27. So column title equals A, they want us to return 1. Column title equals AB, they want us to return 28. Column title's length can be up to 7. This is if only English letters, and is the range between 1 and FX sure XW. So this looks like a base conversion problem, because A is, they're kind of saying that A to Z, we're going to use base 26 because there'll be 26 symbols, and the 26 symbols will be represented by A to Z, where base 10 is 10 symbols, where the symbols are represented with 0 through 9, which is still 10 symbols. So interestingly enough, I think what they're asking us to do is convert base 26 to its actual integer representation. And to do that, we just need an intuition behind how bases are calculated. So if we have 459, this actually expands to 4 times 10 to the 2 plus 4 plus 5 times 10 to the 1 plus 5 times plus 9 times 10 to the 0. So yeah, so if we were to expand this even further, 10 to the 2 is 10 times 10 basically. That is 100, so it's basically 4 times 100 plus 5 times 10 plus 9 times 1. Taken further is 400 plus 50 plus 9. So to do this, what we see is that the only thing that's different is what we're doing is the base of our exponent calculation. So to solve this, what we could do is just iterate over the column title string in reverse. So the last element in a 0 indexed list string array is always the length minus 1. We're going to go while I is greater than or equal to 0, I minus minus. We're going to have a sum variable which equals 0, and I'll delete this line. and we just want to sum these values together. We're also going to want a exponent value which starts at 0, since we're going in reverse. We do sum plus equal the literal value of the number, right? Well, how do we get the literal value of the number? Well, we have A to Z, right? And I'm pretty sure A represents the 65th character in ASCII. And the range, they say, is it only consists of uppercase English letters. This really simplifies the process, because to shift A to 65 to 1, all we'd have to do is subtract 64 from 65 to get 1. And Z, which is actually supposed to equal 26, I think is actually in the position of, its actual ASCII value is actually 91. So if we do 91 minus 64, we should, 91 minus, all right, that would take us too far. So Z 26, I think what we want is actually 90, because 90 would represent Z, I think. If we do 90 minus 64, we would get 26, which is a perfect shift between 1 and 26. So I think we want to go with 64. And so what we can do is we can do column title dot car code at I, which should give us a number, times 26, because we're at base 26, right, to the times 26 to the exponent. So in the case of A, in reverse we get A. We do sum plus equals column title car code at 0, which would be 65, right? And we almost forgot a step, like we said, to shift it. So we do I minus 64 to bring it down to 1 times 26 to the 0, which would be 1. And so it's just 1 times 1. So we're getting non. Input was car code at, we want to subtract 64 from that, not the car code indice itself. So that looks good. So we know capital A starts at 65. Oh God, so sloppy. This is why we should have ran it for all the examples. We're not incrementing exponent, which is why we get 3. Very sloppy. This would be linear time, where n is the number of characters in the string with constant space. So we have number of 1 bits. We did this the other day. So Hamming weight is defined as the number of ones in a number of 1 bits in a number. So write a function that takes an unsigned integer, which means positive only, and returns the number of 1 bits it has, also known as the Hamming weight. It's saying that your implementation detail wouldn't matter, because in Java or some language there's no unsigned integer type. In case the input will be given as a signed integer type, it should not affect your implementation. I was just thinking, I wonder if this would work on an assigned number. So we have to count the number of 1 bits, and you can do this with bit shifting. So if we had 1, 0, 1, 1, we could mask it with 1, which would check the least significant bit. If it does, we'll add it to sum or ham. We don't want it to be const because we're going to be updating it. And then we would eventually keep shifting down n, which is a number, by 1. So to do that, we just need to guarantee that 32 operations happen. We do ham plus equal ham, no, n and 1. Oh, it's probably not good practice to modify input into a function, so we can copy it. Actually, no, it doesn't matter, since in JavaScript this will be copied anyway. So n and 1, and we want to shift it right by 1. Then we could return ham. So if we do ham equals 0, ham plus equals n and 1, that would be 1. Shift n down 1, right? We do another one, that would be 2. Shift n down 1, it would now be 0, 1, all these zeros, right? N and 1 be 0. So we'd shift it down 1, we shift it, check if n and 1 is 1, it is, that'd be 3. Shift it down, we should be able to perform the extra remaining like 29 operations or 28 operations and not have ham be modified. Same case for these. It looks like we're getting, like they said, these numbers all have 32 bits. This function is called many times. How could you optimize it? You could optimize it by using the cheat code that any number ANDed by the number itself minus 1 removes the least, flips the least significant bit to 0. That being the case, we could make the algorithm take exactly the number of operations that are equivalent. The number of operations it would take in this revision would actually be tied to exactly the number of ones actually in the number. To do this version, we would have, well, n is not equal to 0. So after you flip all the least significant bits to 0, eventually you'd flip the last least significant bit, which would be eventually the most significant bit, and the number would equal 0. To do that, ham will always increase by 1, and n would equal the and of n minus 1. God, there's so many problems I'm behind on. It's kind of crazy. So yeah, function is happy. Write an algorithm to determine if a number n is happy. Happy number is a number defined by the following process. Okay, starting with any positive integer, replace the number by the sum of the squares of its digits. Okay, I repeat the process until the number equals 1, where it will stay, or it loops endlessly in a cycle which does not include 1. Those numbers for which this process ends in 1 are happy. Return true if n is a happy number, and false if not. So if n equals 19, you say start with a positive integer, replace the number by the sum of its squares, of its digits. So 1 plus 9 squared equals 82, 8 squared plus 2 squared equals 68, 6 squared plus 8 squared equals 100, 1 squared plus 0 plus, okay, equals 1. Interesting. N equals 2 is not happy, I assume because it goes in a loop. Constraints, n is always at least 1, and it goes to the highest signed highest unsigned 32-bit number. No, the highest signed 32-bit value. So I think there's a few ways this could be done. We could go while n is not equal to 1, right? And if while n is ever equal to 1, we could just return true. We would have escaped this endless while loop. But since this while loop is endless, we need a ending clause, and it seems like the only way for a number to not be happy, it seems to be only two conditions here. Then those numbers for which this process ends in 1 are happy, which is true, and the process where it loops endlessly in a cycle which does not include 1 simply means that it's false. So the only way to know if something is in a cycle, similar to how you would in a linked list, is based on the pretty much portable idea that like you need to know if you've seen something before, right? In a linked list, you usually know that when you've run into the same node with another node, so that'd be the first time they see each other. In this case, we can do it with a set. So our set is going to be here. It's going to be a set of numbers, and if we ever calculating this series of squares ever run into the same number again, we'll know that n isn't happy. So we'll say if n in set, return false. And then we can also just do another modified version. We'll just calculate, we'll just call it calc happy, and it'll take a number and return a number just to simplify the function. So start, we'll say, well, n doesn't equal happy, right? We will calculate this new number. So we'll just call it new num, and we'll call it calc happy of n. And so n, the new number will be the happy version of n. And then we'll check, right? If set.has new num, right? If we've ever seen this number before, then it's a bust, right? Otherwise, n equals new num, and we want to keep going. So what calc happy has to do just has to sum the squares. So to sum the squares, you could probably do this with a reducer. But I think to reduce it first, you'd first need to get it into an array. So maybe we could return n.toString, but spread it into an array .map, where we have, let's just say, an array of strings now. We do parse int s, then we'd have an array of numbers, and then we could reduce a b, and we'll just do a, the previous value is a, b is the current value, so we want to say a plus b squared. So let's check this again. So we give a 19. 19 would go into here, go into a string. We'd spread it into an array. So we have 1, 9. We map it to an array of numbers, and then we reduce it by doing a plus b squared. Let's check if this makes sense. So for n equals 19, create a set. 19 does not equal 1. The new number would be 82 if calc happy works. Have we seen 18 before? No. So we have to do our other case, which is where we just basically add new num to the set. That's why always running the code is a good idea. And then we'll say n equals new num. So now, does 82 equal 1? No. Let's calc happy for 82. It gives us 68. Does the set have 68? Nope. So we add 82 and 68 in the set. Now n equals 68. Then we do the 68 equal 1. No, we calc happy for that. That gives us 100. Have we seen 100 in the set before? No, so we add 100 to the set. Then we do n equals 100. 100 does not equal 1. So we calc happy and then actually equals 1. Have we seen 1 before? No. So we add 1 to the set and n equals 1. Does n not equal 1? It does equal 1, so we exit and return true. So for here, we can actually check for 2. So check if it handles this correctly. Does 2 equal 1? Does 2 not equal 1? It doesn't, so we calc happy for that. It's going to be 4. Have we seen 4 in the map before? We have not, so we add it to the map. N equals 4. So what we have in the map so far is is 4. Does 4 equal 1? Nope. So we're going to keep going. Calc happy. That's going to give us 16. Right, 16 is in the map, so we add to the map. N equals 16. Then we do the square of 1 plus 6 squared. 6 squared is 36, plus 1 is 37. Have we seen 37 before? Nope, so we add it to the map. N equals 37. We do 3 squared, which is 9. 7 squared is 49. 49 plus 9. 49 plus 9 gives us 58. So now we have 58. Add 58 to the map. So 8 squared is 64. 64 plus 25 is 89. Then we do 8 plus 9 squared is 64 plus 81. Plus 81 gives 6 plus 8 is 14. Gives us 145. Then we sum those together. 4 squared is 16. 16 plus 25 is 41 equals 42. 4 squared is 16 plus 2 squared is 4 is 20. 2 squared is 4, and then we have a loop. Geez, so I think this should work. So 19 actually returns false, which is strange. Actually, I'm curious if calc happy is producing the correct. I'm curious if calc happy is producing the correct value, so I'm just going to run it. 19 gives us 82. 82 should not give us 12. So, okay, so something is wrong here with calc happy. 19 gives us 82. Right, so then new n should equal new num. Except when we do n and new num, we're getting 12. 8 squared should be a squared plus b squared. Yeah, I really don't understand how reduced functions work. I think we actually just happened to get lucky with the first calculation. It looks like calc happy. So the previous value is empty, the current value, and then the previous value. But how are we not continually squaring the previous value over and over again? So I definitely need to do some review on how reduced functions work. But this seems to work, so let's try it. So for 7, we get false, even though we expected true. I'm wondering if I print this again, if we have a similar case. That doesn't make sense. 7 squared should be 49. If we do n to string, which is 7, spread it into array, we part the array. Yeah, let's just go for a safer version. And we'll just do it like this. We'll keep some of what we had going because it was useful. I think we just want to stop at the reduce part. And then we can just do for each num, we'll do sum plus equals num squared. And then we can just return sum. Oops. Why is sum an array? This should be a number. Oh, brother. So this looks good. There were just some issues properly using reduce, saying detect cycles with a hash. This is what we're doing here basically. So they actually create a function called getNext. Interesting. It looks like to take a number off the end of a number, you just divide it by 10. Or you have to mod it by 10. So if we wanted... Oh, I guess that does make sense. But to push that number forward, you could... Okay. Okay, that's a cool way to do it. N divided by 10. I'll keep that in mind. So if we do N, which is 49, mod 10, we get 9, which is the number at the end. Now we want to push this down to 4, so we could do 49 divided by 10, which would give us 4.9. In JavaScript, we'd have to floor that, though, just to make sure we're safe. Interesting. So they actually found a way to implement fluid cycle finding algorithm similar to how you would do it for linked lists. And for one, you're calling getNext, which starts at n, and one which starts at getNext n. So that's pretty cool. This one is log of n. I wonder why that is. Interesting. Jeez, yeah, some of these are really in depth. I would take that as a solution. The takeaway from this problem, I don't understand reduce that well. You can use modulus 10 to pull a number off the end of a digit, then divide by 10 to pop that number off and keep the rest of the number. And it could be used for fluid cycle finding. Could be used with fluid cycle finding algorithm. Algorithms are pretty portable in the end, so that's pretty cool. Yeah, I didn't realize I was behind on so many problems. That's pretty bad. So your function is palindrome. Now restart it. Given the head of a singly linked list, return true if it is a palindrome. So we have 1, 2, 2, 1, 1, 2. Palindrome is an object that is the same forwards as it is backwards. So we have 1, 2, 2, 1. Interesting. Do the return if it's a palindrome. You could do this with linear time and linear space. If you use the stack, you could just push off the number, pop the number on. You could, going too fast. You could iterate over the linked list, push onto stack, progress LL, iterate over LL again, check values, right? And if it's false, we return false, otherwise we return true. That'd be linear time and linear space. So let's try that version first. So we'll do it with a stack, which we're just going to use as an array. I have a temporary value which points to head, and we'll do while head does not equal null. We'll do stack.push head, nope, not head, temp. We'll do temp dot val, and we'll do temp equals temp dot next. Then you can iterate over the linked list again, and then reset temp back to head. And in this case, we can just pop them off in reverse and check if they are the same. Ideally, since temp mirrors the number of elements in stack, we don't have to actually do, and stack.length is not empty. We'll do while temp does not equal null, and we'll do while, we'll check the values. If temp.val does not equal stack.pop, it will return false. Then we can do temp equals temp.next. If we make it all the way out here, we can return true that they are indeed palindromes. Delete the pseudocode, push. So stack would be an array, and we're only going to operate at the end of, and so we would, while temp is equal to head, while temp does not equal null, temp is not null, we'd push 1 onto the stack, we'd go to the next one, we'd push 2 onto the stack, go to the next one, push 2 onto the stack, go to the next one, push 1 onto the stack, go to the next one, temp would be null, we'd push temp back to the front, and now we would have 1, 2, 2, 1 in our stack, starting back over at 1, 2, 2, 1. So for here, we would say while temp is not null, 1 is not null. Does temp's value, which is 1, does it not equal stack.pop, which is also 1? It does. We go to the next one. Does 2 equal stack.pop, which would be this one? We'd go to the next one. Does 2 equals stack.pop again? We'd be good. And then we'd go here. They'd both be at the ends again. Does 1 equal 1? It does. Temp would now be null since we'd go to the next one, and then we could return true. So there, this would be done with linear time and linear space, since we have to keep a stack. To do that, and the stack is going to mirror the number of nodes that exist in the linked list. Now to check, to do the follow-up, right, the number of nodes in the list can be up to 1 to 10 to the 5. Could you do it linear time and constant space? We could if we're allowed to modify the data structure of list node, what we could do is just reverse the what we could do, and I think this is also because we're in JavaScript, we could just add a property to the list node, right, that turns into a doubly linked list, and from there we could just iterate back in reverse. So we could turn head into a delinked list, all right, then iterate while, and then we do the same checking, right? We would do while temp, it's not, we could just, I would just say iterate over head again. And we could check if head dot val does not equal temp dot val, right? Return false. Otherwise, we'd say head equal head dot next, and temp equals, or we'll call it tail. It's easier to call it. We'll just call it L2 and L1. L1 is incrementing towards the center, while L2 is incrementing towards the center in reverse. That being the case, L2.next will actually be L2.prev. And if they make it out here, we would return true. So how do we return head into a delinked list? I think you can do it with the two-pointer approach, with the goal being that we'd have a temporary pointer, or not two-pointer, I guess it's slow and fast. It's not really slow and fast, it's really just two pointers, just one starts behind. So we'd have basically a temp node and a ptemp node, and the temp really starts at head, right? Ptemp starts at null, right? And this while loop is going to run while temp does not equal null, right? And the goal here is just to move forward, right? And while we move forward, we'll have a reference to the previous node and the current node. So when we start, temp will be head and ptemp will be back here, which will be nothing. And so we'll say and I'm realizing we actually don't want to start at head because it's just a little more complicated. We want to start temp at head.next and ptemp at head. So temp will start here and ptemp will start at 1, and we know this is fine since there's already at least one node to start. So while temp does not equal null, what we want to do is we want to link them up, right? So we want to link temp.prev to ptemp, right? So we could say temp.prev equals ptemp. So now we're lining them backwards, right? And then we can do ptemp equals temp, and then temp equals temp.next. And so we go 1 and 2, right? Temp.prev would be equal to ptemp, then we go ptemp equals 2, and then temp equals temp.next, which is 2. We tie temp.prev to ptemp, right? And then we go temp equals temp.next to 2, temp equals temp.next to 1, do temp.prev equals ptemp, right? And then ptemp equals temp, which is 1, then temp equals temp.next, which is null, and then temp will be null, so we'll stop, and it's perfect because ptemp will be pointing to the tail, And so we can just go in reverse from there. So that works. So we can implement this now. We'll let temp equals temp.next. And we'll do that ptemp equals head. We'll do while temp is not equal null. I think we just uncomment these. Temp.prev equals ptemp. Ptemp equals temp. Temp equals temp.next. Prev equals ptemp. Temp equals temp. Temp next. So now we can just iterate over head again. To do that, we can just set temp back equal to head. And now temp represents head and ptemp represents tail, right? And again, we can just iterate while temp is not equal null. Since they're sharing the same data structure, which is this list node, this linked list, we don't have to worry about both of them not being null, since it's a pairwise iteration, so they're going to match each other in terms of like the inverse indice at the same time. What I mean by that is when temp is null, ptemp will also be null since they're iterating towards each other. So we'll check, right? It's like we said, if temp.val does not equal ptemp.val, right? We want to return false for sure. And we'll change temp equals temp.next and ptemp equals ptemp.prev, and then we can return true if we make it out of here. So this looks good. Let's check it just real quick. For this, we have, I said let's check it, but there's only 8 minutes left. So ptemp does not exist on list node. I think this might be a TS error. That's the case. Let's change both of these to dlist nodes. And we'll say interface dlist node extends list node, and we'll just say prev, and it can be a dlist node or null. Let's try that. So I'm not understanding. This is a TS error. Property prev does not exist on type list node. I think you could safe navigate it, but I think yeah, I'm not understanding why can't, I mean, I've already extended the type, so what's the problem here? Property prev does not exist on type list node. Yes, that is why I extended it up here. If this was JavaScript, it would not prove does not exist on type list node. I don't know what they're injecting into this code. I'm just gonna do something like dlist node looks like it doesn't care about my redeclarations. Property pre does not exist on type list node. Pre does not exist. That doesn't make sense. You know, I'm just gonna copy. I'm pretty sure this is just a TypeScript error, but if I would choose, I'm just gonna copy this, take this to JavaScript. Ooh, and nothing copied at all. So this works, and we just showed that it works, but I don't know what they're injecting into this environment because I literally can't change list node, or I can't extend it. It doesn't make sense because you can always extend stuff. I would just say type dlist node equals yeah, for some reason it does not care. This is a list node no matter what. So words we change head to any. If I don't understand, I extended the interface, but I still can't do anything. That is just strange, to be honest. Ah, I did a head as any. Okay, that's what I did in the past. That's very interesting. Ah, interesting. So you could have one go fast, one go slow. Once the fast one reaches the end, you're exactly at the halfway point. Interesting. Takeaways from this problem. I couldn't figure out how to get the types to work, but I don't know if that's because I don't understand how TypeScript works or something, or if this is just like a limitation of LeetCode. Second takeaway, reversing or turning a linked list into a doubly linked list is always an option. Or when doing something with constant space, modifying the input is usually the case. Another takeaway is another way you could have solved this, supposedly by what they said, is that we could have iterated through found the halfway point in the array. Found the halfway point in the linked list, and then reversed the second half of the linked list, and then just iterated sequentially. That seemed a little involved. And that also you could use recursion for checking if something is a palindrome. So that is pretty cool. I just want to see what the next problem is, but I'm not going to do it. Yeah, we did a lot of maintenance today. We should probably still do a new problem. I keep saying I'm going to come back to LRU cache, but we already started insert interval. So I feel like we have to do it just to knock it off the plate. But it shouldn't be too bad. I already know how to do it. There was just one problem with inserting an element into an array that for some reason I'm incapable of doing. So I don't think this one should take 20 minutes, but we're going to see if we can do it really fast. And then we can do LRU cache. So you have function insert, we have intervals, which is a matrix of numbers. We have new intervals, which is a tuple, and we're returning this matrix. We're given an array of non-overlapping intervals, where intervals sub I equals start I, end I, representing the start and the end of the ith interval, and intervals sorted in ascending order by start sub I. You're also given an interval, new interval, start comma end, that represents the start and end of another interval.
I was actually